Hello, good morning, and welcome to my shop. Here it's January 18th. Still pretty cold with some snow threatening to come later today. Not a lot, just a bit. So, what's going on with this radio? Now, that's a good question because things have gotten just a little odd here. So, with the volume turned up full and a strong signal into the antenna, we could hear a station coming out of the speaker, but very, very weak indeed. I got curious about the switch here. This switch is intended to allow either the use of this input or listening to the radio, one or the other. So we're going to take a look at how this has been installed. The thing about the switch is it's jammed in one position. And when I'm going to double check this. When I check to see what is going on with these two wired contacts, I found them to be open, but I gotta kind of wonder about that. Let's check them again. Something is not adding up. That certainly does seem to be open. Now the other terminals here should show closed. They also shows closed. So the switch is stuck in the open position. And actually I don't know which way is supposed to be which, but we'll find out in a moment. Switch, so the wires are open circuit right now. If the switch were in the other position, it looks like they would be closed. We take a look at the panel here. The radio is up and the auxiliary input is down. Put a small red mark there, which should match the small red mark on here. Uh-oh. Looks like I've rubbed off the red mark. Well, that's not too good. Okay, well, we'll have to go on the wire hanging technique here. Yeah, magic marker's not going to last. I was trying not to rub it off, but I did. And the marker's on the bottom. Marker's on the top. Marker's on the top. The mark is on the top. It doesn't really matter. We go by the way the wires were hanging, which I don't think I bent these, so they were hanging like this. So this is stuck in the up position. The up position, and the up position is supposed to be the radio. So we should be hearing the radio. Now, weirder than that, when I shorted this, expecting some change to take place, nothing happened in the radio. No clicking, no popping, the radio didn't come on, nothing happened whatsoever. So let's just take a look at how this wiring's done. In the radio, the owner has assured me that the switch was doing the right thing for him. But this radio is pretty simple in how it handles this connection to the to Phono. Like if you want to play Phono, play a record, you would, assuming this is the very same Phono Phono plug. This is the original Phono plug. Pretty good assumption because it's got to be the original. It's got rivets here holding it, and the rivets are covered by this paper tape. So, okay, original one. There is no switch incorporated in this. Occasionally, you'll get one of these with a switch incorporated in it. And I'm looking for something here. Here we are. So this is just some coils, but they have a Phono plug on the end. Look at the Phono plug. Look at how long this shaft is. That's crazy. I mean, most Phono plugs have just a short little shaft. Why so long? It's crazy long. because there's a switch incorporated back here on some of these. When you push this in, this prod goes far enough in to open the switch, and that turns off the radio signal from continuing to the amplifier and replaces it with whatever's coming in the input. That's not the case with this radio. This radio does not have a switch. So another way of doing this is you plug in your alternate source, and then so you don't hear the radio, you tune to a place where there's no station and no noise. You might even disconnect the antenna. I suppose you could do that too, to try to silence the radio, because the radio signal's still there, still connected and ready to come out of the speaker, even though you've plugged in your phono. Now, there could be some impedance thing happening here where the phono impedance is low and the circuit itself coming from the radio is very high, so in a sense when you plug in the phono you short out the radio right through the phono cartridge or something like that. That sounds kind of crazy to me. Doesn't sound like a very ideal way of doing it. This thing about tune the radio to a spot is there is something odd going on here. Tuning the radio to a spot, that's a pretty sloppy way of handling the phono input. But I've read that right in the instructions for some radios. It's exactly what they say. So crazy as it might be. So let's look at the actual wiring here. So the wires that were added in, one going of course to the phono, the other one going down to where I can see there was a wire here. See, there's a wire here that's been cut, and then the wire's been replaced by the switch. So switch is closed, same thing as having a wire here. Switch is open. At that point there's no phono connection into the radio. Now, at what point does the radio connection get broken? There doesn't seem to be any opportunity to stop the radio signal here. We should take a look at the schematic for this radio. That's what comes to mind here, just to double check. So I'm gonna try to get the schematic here. We'll take a look. Okay, so this is Radio Museum I'm looking at, and yeah, so the radio says on it chassis number 49, and I almost freaked out when I saw the 49. Oh my gosh, there's 150 49s in here with an extension number. But luckily, if you look at the top, you can see two of them are Canadian built, but one of them is just called the 49 with a T. So we click on that, and there it is. At least, I'm not sure what the T is for, but it looks exactly like the radio I have. The unfortunate is $66. The unfortunate thing is there's no schematic here. I gotta go hunting somewhere else for the schematic. What can we find out here? 4142, 1941, 1942, according to this. Philco Products Toronto. The T could stand for Toronto. That's about it. Okay, I'm going to go hunting somewhere else. In fact, you want to come with me? Come with me here. We're going to go to Pacific TV on the west coast of Canada. Online schematics for Canadian, mostly Canadian radios, but I think it probably has more stuff. We're looking for Philco. So here it says 2 with a semicolon, 2 radio schematics. And now we're looking for Philco. Now we want to find Philco 49, 490. This might take some hunting to spot it. Yeah, I mean, you shouldn't have come with me for this ride. 37, 37, 38. The numbers seem to be jumping around. 49 and 52. AC Radio Service Manual. Philco 49. Well, that looks like it. Let's find out. Models 49 and 52. 4 bands. Well, this is probably it. Oh, this is a really long write-up on this radio. Here we are. Now, is this the radio I've got? So we're looking at a 7, a 7, and a 7. So these are the Lochtel tubes that are numbered with a 7, and that's what's in the radio. The 6K6 could be. I don't know what output tubes in there offhand. 6J8. Not the most common tube. 6J. I think this is it. Transformer there, IF can there and there. I'm just looking at the radio. Its layout is exactly as we see it here. Oh, they're only showing 2 knobs, but they could be hidden. The other 2 can be hidden. Look in here. Of course, there's got to be. I think this is the radio. I think this is it. Ooh, this is the model 52, and this is the model 49 here. Notice there's no T or anything like that. This has got to be it. Here's the actual component layout chart also. Excellent. Okay, what we wanted to look at, excuse me, on the schematic is a couple things. First, the power supply. So they're using, so this that block capacitor I talked about before, this is where it's sitting, right in this area here. And this, I think we need to get rid of this and change it with something more reliable before we get into trouble with this old block guy. Okay, so field coil in the speaker, and it looks like they're pulling arranging a negative bias on this line here. Yep, up to the. Wait a minute, something not right here. Something's not right. Why am I thinking? Because I'm remembering the car radio I worked on just a while ago. Everything is fine. I'm just getting it mixed up in my head. And we have a tone switch. No, it's not a tone switch in this radio. It's a potentiometer. Okay, well, you can't be too surprised to find the odd difference. Here's the jack on the back. They're showing a different style of jack here, but I don't think it matters. So now, you can see the jack is just connected right to this wire. There's no switch. There's nothing going on here. So the signal from the radio, which is being developed right here, through the volume control and onwards, and if you plug in here, well, that's a little odd. What are they doing here? They're sending the this doesn't look right, actually. What are they doing there? They want the audio to get to the top of this volume control. And they could just hook this wire straight here. But instead, they've got it going up, connecting into the sort of top side of the second IF. Why in heaven's name would they do that? I've never seen anything quite like this before. Maybe this method will, when you plug in here, if this were a low impedance, just to back up, this circuit here, the impedance of this circuit is very high. If you plugged in a low impedance cartridge here, you would bleed down. I don't know what they're doing. Why are they doing this? Yeah, I can only guess that it somehow plugging in something here draws down the radio signal because of the way they've done this. but it sure seems odd. I mean, this is going up to the detector. Isn't this going to get half rectified up here? That's really weird. So going back to the switch. So the switch is just inserted right here. So you're either connecting the external in or you're not. The other thing is, there's a DC voltage here. That DC voltage is going to head right back out into whatever device you plug in here. Man, but it works. I mean, it works when it worked. In other words, you could plug something in, throw the switch, hear the thing, iPod, whatever it might be you've got going, throw the switch the other way, you get the radio. Or to get the radio, you need to unplug and throw this. We don't need to even throw the switch. The switch is just, it's not really doing all that much, except it's stuck open. Oh my gosh. Now, why would there be no or very weak sound? Well, the possibility of defective tubes here. We need to test certainly this tube. And we should be putting a voltmeter on here and just poking around a bit, see what kind of voltage showing up here, because it will be impressed on whatever's plugged in. If what is plugged in happens to have a capacitor in it somehow, then maybe it's all okay. But I would be a little anxious here. So what I would tend to use is a double throw single pole switch, and select from here either this or this, one or the other. Wait a minute, this is going the wrong way. This isn't even the right wire I'm fooling with. It'd be this one, the input to the volume control. So I would arrange a switch from here that selects either this, which is the radio, or this, and break this connection. Okay, it's kind of weird. Definitely strange. Yeah, I think we should test these two tubes next, and just see what we got going with them, in case that's the real cause of the problem. Okay, tube testing. Okay, let's start with the output tube. It'll be this tall one here. This one is a 6K6. That's what's listed on the radio. It says Philco on it, so there's a chance this is an original tube also. 6K6 is a fairly popular output tube. Over here. Now this is a emissions tester, but it's kind of like a high quality emissions tester. 6K6, let's find it on the dial here. K6 right here. Okay, 6.3 filament voltage, and we'll push 1, 2, 3, and 4, 5, 6. 50 on the big wheel. We test the tube by pushing a W. 1, 2, 3, 4, 5, 6, and 50. Yep. Okay. Plug this guy in. You know what, the switch is on, but the light is not on. It must not be plugged in. Here. Let me put this back here. How about it is plugged in, but the... There we go. Okay, now we're cooking. You can see it heating up here. Give it a moment. The first test will be to see if there's a short inside the tube, and then we'll actually test the tube itself. So we're watching the light here to see if it stays on in any one of these settings. Little flash is actually good. Did not stay on. There were no shorts being detected. W is the test. This is just a good or bad. So it's testing low. Doesn't mean it doesn't work. Could this be responsible for the low output? It's very low output. I'm not sure. I need to test this maybe in another tube tester. So we're not unsure of the 6K6, but it looks weak. That's how we would conclude that. And the next tube we want to test would be the detector tube. And I think that's a 6C5. Let me just double check here. Oh, 6C6. 6C6. Yeah, detector tube. That's this guy. 6C6 up here on the top. So the 7C6. This 7 that these tubes are numbered with would have been a 6, except they decided to make a 7, and that would identify that it's a Lochtel style tube. So when you see a 7, doesn't mean 7 volts. It's still 6.3 volts. The 7 means it's got a Lochtel base on it. Now I've got a Lochtel. Here we are, right here. Okay, so 7C6. 7C6. So we will look that up. C6, there it is. That's 3 tests because it's actually got 2 diodes and a triode in it. It's a multifunction tube. We pop the buttons up. This release here, and now we depress A1, 2, 3. A1, 2, 3, and the bottom row is A45. A45. 65 on the big wheel. WX for the test. Okay, in you go. These tubes seem to be popular for a short period of time. I don't know how many years, but they eventually just went away again. Maybe because I think these are really meant for putting in cars, so they don't shake out of the sockets. But you do find them in various radios, including the one I'm working on right now. Okay, here we go, watching the short light. Looks pretty normal. And we will push, is it WX? WX. WX. Here we go. It's also testing weak, and you probably can't see this, but the pointer is falling during the test. That's also not the best indication. 2 tubes. 2 tubes, both testing a little low. The 2 in combination. So what did I just test? So I'm pretty sure I just tested the triode. A weak triode followed by a weak amplifier. So when the radio failed, the radio was playing normally, and then over the course of about 5 minutes it faded down into almost nothing, or nothing. You know, I guess a tube failing could do that, I guess. I don't know what would do that exactly that fast. A resistor burning up? I don't know. Mysterious. Could this tube in combination with the other tube result in the very weak output? I don't think so. Even though this is weak, let's do it again. WX. You know, it's not like it's, you know, good here and bad there. That's not the way the world works. Let's do the next test. So we pop the bottom row and replace it with a 6. And we dial this all the way up to 80. And now we push X. So now we're testing one of the 2 diodes. And it's also testing low. And the other diode, we push 8 and do the same test. X, very low. Well, I would deduce that there's a worn out cathode in this tube. And that's why it's testing low on all accounts. Well, but could it account for the very, very dead output? I just don't think so. I think you can get low volume, but I better put it in the right socket. You could get very low volume, but I don't think it would be like knocked right out. So another tube that's worth doing is the rectifier tube. This would be the rectifier tube down here, because maybe the B plus is low. I haven't tested it. This is a 7Y4 rectifier tube. Okay, notice the number of the pins are missing here. Doesn't need them. Whoop! Number of the pins are missing there. Doesn't need them. Oh, you're looking way up. Look back down. Okay, 7Y4. 7Y4. 6.3. 1, 2, 3 again. And then 5. 18. Push W for the test. The rectifier tube and the output tube are the hard working tubes in a radio like this. They're the ones that are going to wear out just through use first. The other tubes are just loafing along. Okay, we'll look for shorts. Nope. 7Y4. 18. Push W. That test good. Now there's a second test. Push in 6. And push W again. So the rectifier is not the problem. That's for sure. Very good. So, so we can't be sure whether the tubes are really part of the problem or not. What to do next? Maybe we'll do a little signal tracing. We'll listen to the signal that's coming out of the IF and try to judge it. And also, just the way this is done, it cannot interfere with the operation of the radio. The radio should be operating all the time here. So this is not implicated at all, especially with the switch apparently stuck open. It's basically not even, none of this is even there electrically. Okay, let's try a little signal tracing next. Let's have another look at the schematic here. I'm looking for where I can take my signal tracer probe and pick up the output of the IF string. So right in, this is the IF string, the two transformers, and I want to pick up the output from here. So I have a couple places. The most typical spot is top of the volume control. We should have maximum audio output from the radio sitting here. So if I test it here and find it weak, then we know there's trouble back this way, which I don't think is very likely to happen. But they've done something different in this radio. Like if you look over here at the big resistor, this is the AVC resistor, I guess we can call it that. And so they're taking the rectified output of the IF and using some of the scrap DC voltage to drive automatic volume on these first couple tubes. Maybe this one only, in fact. Yeah, looks like only on this tube are they doing the automatic volume control. Wow, sneaking my way all the way through all this. Now, the difference here is usually the AVC voltage is tapped off right here. Usually after this filter. And I think the thinking there is the filter's beneficial, and you really don't want RF making it up into the grid of one of these first two tubes. You just want DC voltage changing the bias of the grids on the first two tubes. So on this radio, apparently not this one. Oh, wait a minute, look at this. What's this wire doing? So this wire is conveying the AVC voltage over to the grid. They put a big 1 meg resistor here to try to isolate things, and then it goes right on the grid. There's just a drafting problem here. This continues here. Okay, so both tubes controlled. That's normal through the AVC voltage. But the AVC voltage, which is normally tapped off here in this radio, is tapped off here. Why? What's the advantage of this? And then, which I noticed earlier, oddly enough, the auxiliary signal is sent up to here. And on this wire, there's going to be, it could be 15 volts DC sitting on this wire from the rectification action of the output of the IF. And then that voltage is just put right across whatever you plug in here. Not the best deal. So and then they send the AVC voltage. It's filtered. I guess they're just relying on this filter. This is actually more than just a filter trying to ground out any RF that's over here. It's also the AVC bucket, if you like, that is filled through this resistor, and this guy holds the AVC voltage, dampens it or steadies it, however you want to look at it. So the AVC voltage is not likely to vary rapidly, and also any RF, stuff like that, is going to get knocked down through this capacitor, particularly if there's a resistor in here, but there isn't one. So I mean, there's one over here for this tube. Okay, well, it is what it is. So where would I tap for a signal? Well, the best place would be to start top of the volume control, and then we could back up to the top of this resistor. Possible killers here: this capacitor is defective, or this one's defective. If it's developed a short, that would kill the radio. This one going open, that would mean no sound gets through anymore. I mean, there's lots of possibilities here. But we know this tube's good, and we know, actually we don't. We know this tube's weak, and this one's weak. And the question would be, 2 weeks in a row makes the output go low. Hey, that's a rhyme. Okay, let's sniff around. We'll poke around here. I can certainly find this spot easy enough. I can find this spot fairly easily. You just have to look in the tube manual, get the pin number. I think I've seen this resistor, so I already know where this is. I know where this is. Oh, therefore I do already know where this is. So really, we're looking at top of the volume control and this point, and listening. And what we're hearing is right at the diodes and other side of the filter is the two things we're doing. Okay, I think I know what I'm doing. Always a dangerous situation when I think I know what I'm doing. That spells danger. So we're going to use the signal tracer here. This is the signal tracer ground, which I'm going to clip onto the chassis. This great big probe here is a big honking thing because there's actually a vacuum tube in here, and the grid is connected to this. Oh, scare myself. It's working. It's working. Okay. I need to turn on the radio. I have the antenna connected and switched on. Radio's plugged in. Here we go. Okay. Now, I did get an email about saying, hey, I think the on-off switch is on the tone control, as if, did I misspeak in the last video at some point? The on-off switch is on the tone control. There's no doubt about that. Okay, so now volume. Can you hear it? I can hear it. Volume 0. Volume max, ever so slightly more. And volume maxed, I hear a bit of noise. It sounds like open grid kind of noise. High impedance grid. The grid's acting like an antenna. I don't know what to make of it. Not much. Okay, so we want to go on. First of all, we'll go at the top of the volume control. And the volume control is over here. And the top is hard to figure out, but it's one end or the other. So we're going to, with the volume in the middle, not that it matters much, we're going on the input side, or this is the input side. There we are, look at that. Well, lots of
I guess we'll take that back. Yeah, it's not very good. The Purple train in particular, because that was also a guy that was a pending free agent and a guy that they gave a first round pick for, and they got.
So that's what the radio's producing. It's producing its signal just fine. Now that signal is supposed to go. That signal should be here also.
You can compare Yakov Purple train to a Pascal.
The signal should not be here. It should not be there. How's it getting there? Through this switch?
I'm just trying to stop. Yakov looks like Raptors fans were with Yakov Purple, but what do you think was more realistic? The pace. It's just gonna happen. Pacer sign, Seattle.
Well, I have to look at the schematic, but maybe the signal's coming at the switch from both sides, because it's yeah, I'd have to look at the schematic. Okay, so lots of radio signal, nothing coming out of the speaker. I'm going to pull this out. Not that I think it can do anything, but just in case, fat chance. And incidentally, this is all mono stuff. Lucky arrangement. It happens to fit right in and stick right out to the back of the radio perfectly. It's actually quite a clever, or quite a lucky deal there. But it's not helping with the radio at all. I still can't do anything with the switch. Switch seems to be, yeah, we don't know. I think the signal's getting to. Well, you know what? There's no chance of the signal getting to one side of the switch because it's just here. It's to nowhere. So the switch must be like a high resistance. It's gone faulty. That's really weird. This is strange stuff here. Strange stuff. Now what we need to do now is inject a signal. Maybe onto the grid of the output tube and hear what happens. I think that'd be a good idea. And I can do a sloppy job of that just by using my finger if I dare. And I just need a nice screwdriver for that purpose. I don't really have a nice beauty. We'll use this broken one because I never use it for anything else. I'll tap the end of it there. We need to find out the grid of the output tube. Grid of the output tube. The output tube was a 6K6. Okay, 6K6. 6K6. Grid is number 5. Pin number 5 is the grid. Yeah. Number 5. Okay, so first of all, I'm going to just tap it with just the metal here. I'm not going to be touching it. So we just hear some clicking or stuff like that. Pin number 5 of this tube here. Okay, so I'm looking for the key. There's the key. Excuse me. 1, 2, 3, 4. This is 5. Here. Volume up. Okay, now I'm going to touch the end of this. Not recommended unless you've got this radio set up safely with an isolation transformer. I'm wearing rubber-soled shoes. I'm standing on a rubber mat on top of a tiled floor on top of concrete in the basement. So I would not recommend this. On the other hand, very, very dangerous if you put it in the wrong spot while you're doing this. So for me, it goes behind my back. Here we go. Oh, can't. Got to turn the volume down because this could be very loud. Okay, there we go. Okay, we'll turn the volume up. Not very loud. Here we go. That's pretty darn quiet. Volume doesn't matter on this either, Jim. So normally the signal level in my body should be sufficient to make a huge difference out of that speaker. So I would add 2 things together now. Weak tube test, a weak test that I just did now, although this is a very uncontrolled way of doing it. Sure looks like the 6K6 has gone quiet. I think the next logical thing would be to replace the 6K6 with another 6K6 and see if we get somewhere like that. That's the next logical step. Okay, got a 6K6 in the machine. We'll look for shorts. No. The test is W. Set to 50. W. Oh, she's in the good. Okay, so we'll pop this guy in the radio. 6K6. And see if this doesn't improve things right here. Okay, that was not the tube. That was my flashlight going down. 6K6. Okay, Mr. Radio, what do you do now? Okay, power on. There she goes. Volume's down. Antenna's connected. Radio's tuned to a station because we heard it. And volume up. Oh, we're getting a little more. Tuning. Tone. Band switch. Sometimes the band switch can be sticky. No. Okay, we got a little more out of it that way. But I think now we got to try and replace the detector tube, and then we can eliminate those tubes as being a cause of the weakness. You know what? I'm operating this with only 94 volts. Oh! Volume down. 94. That's a little low. Didn't make much difference, except I got some kind of hum developed in this thing. Where's that coming from? Right out of the speaker. Yeah, it's still there. It's just quiet when you're on 94 volts. You know what I should do? I haven't done. Let's check the B plus. I should have done that. That was on my list of things to do, and I didn't do it. B plus is going to be 250 volts or so, something like that. Let's see what we get. So I'm going to check right on the end of these capacitors here. 176. And we are operating with low. I put the full voltage on. 211, and the other capacitors here. 211 also. A little surprising, I mean, almost exactly the same voltage, 210.8. 210.3. 210, well, that's enough to operate the radio. It's not zero, that's for sure. Yes, we're going to need to replace the detector tube. So I've got to go hunt one down. Well, I have not been able to find my box of 7-volt tubes, so I have to do a bit of a digger deep. I have to dig a little deeper, and I've run out of time today, so we're going to have to stop right here, looking for a replacement for a 7C6 Lochtel tube. Okay, unfortunately, I'm not going to find out if that's really going to fix the radio or not today. Maybe tomorrow. So, thanks a lot for watching, and see you tomorrow with a 7C6, hopefully.